Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. My name is Ariella, and I'm joined by the recent astrophysics master's graduate, Kshitij.
Hi. That's
you. And the astrophotography extraordinaire, Sana.
Hi.
We're broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. This is Astronomy Night in Canada, where the lineup is all Canadian. Starting with ourselves, York Universe, then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 2 a.m. UT for EST, or 1 a.m. UT for EDT. The York Universe production works in concert with our online public viewing program run by the Observatory team, Hi Guys, which runs between the hours of 9 p.m. to 10 p.m. local Toronto time. Please go to observatory.info.yorku.ca and follow the links to OPV, which is online public viewing, and join the chat. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have about our past shows or this one, or suggestions for future topics, please send us an email at observe@yorku.ca. We will be monitoring the chat room for questions and to post content. The current weather is, and I should have actually looked outside my window, but it doesn't look that great, and for the last few days we've had horrific thunderstorms here in Toronto and the GTA. And it has not been too good for telescope viewing, right guys?
No. I think they're doing live viewing. They were talking in the chat earlier about doing some live OPV viewing, so.
Oh, hopefully it stays good, because I looked out my window a little while ago and it was cloudy, but I'm a hermit, so I haven't looked in a little while.
Yeah, when I want to see the weather, instead of just looking outside, I Google it.
Yeah.
I don't know why.
That's smart. Well, I did mention that Kshitij is a recent graduate, so congratulations from York with your master's, and Sana is soon to be starting hers in a couple weeks. So how does it feel to be going back to school, Sana?
It feels good. I'm excited.
Are you?
Yeah. I'm actually excited to start it because the courses I'm taking this year are looking interesting, and my research project is also very interesting, so it should be fun.
I say this too as if I'm not also starting school again.
Yeah, and I'm most excited that you're going to be back.
Yes, I will be back, and Sana and I will have classes together, which just means simply trouble for all of York University.
Oh, yeah.
We do have a really interesting night and a really cool topic. Sadly, Pluto is not mentioned, but I will mention it periodically just since I'm hosting. But why don't we get started with this week in space astronomy history? And I think, Sana, you will be kicking us off talking about the Voyager 1 launch.
Yes. So the Voyager 1 spacecraft launched on September 5th, 1977 from Cape Canaveral in Florida at Launch Complex 41 aboard a Titan Centaur rocket. The goal of the Voyager 1 mission, as with the Voyager 2 mission, was to study the outer solar system, and Voyager 1 accomplished this by doing flybys of Jupiter and Saturn. Both of the Voyager missions were incredibly successful, by all accounts. Voyager 1 accomplished everything that it was meant to and much, much more, and made a ton of important discoveries about our solar system. So just a couple of highlights, I guess, from the mission. While Voyager 1 was at Jupiter, it discovered a thin ring around Jupiter and took observations that helped to shape its atmospheric models. It also made some groundbreaking discoveries about Jupiter's moons, including the discovery of 2 new moons and the discovery of volcanism on the moon Io, which revolutionized scientists' view of the moons of the outer solar system at the time. It made some equally important observations while it was at Saturn. It took detailed observations of Saturn's magnetic field, identified a new ring called the G ring, and also studied how Saturn's moons interacted with and stabilized its F ring. It also discovered 5 new moons, showed that Saturn's moons likely have water ice, and revealed that Titan has a thick nitrogen atmosphere that might allow for some liquid, not water, but liquid nonetheless, to exist on its surface. Now, some of the moons in the outer solar system are some of the most interesting targets for space exploration, and there's actually some missions that are planning to go to them. And I think some of the observations from Voyager 1 had influenced, it kind of sparked some curiosity about what do these things look like, and for some further investigation. So really great discoveries that it made while it was at Jupiter and Saturn. Well, after completing those flybys in 1989, it began its interstellar mission in January 1990, this time with the goal of studying the solar system beyond just the outer planets and starting to look towards the outer limits of the sun's sphere of influence, which had never really been done. It was the furthest thing out in the solar system at this point, or almost was. So these were really groundbreaking observations. Much like the earlier observations, which were part of the Jovian mission, Voyager 1 has done a ton of notable things during this part of the mission. One of the first things that it did was take a series of images that I think are pretty famous now, or somewhat famous, which are known as the Solar System Family Portrait, or the way that I've always heard it was the pale blue dot image. It's a mosaic that was constructed out of 60 images that Voyager 1 took when it was about 40 astronomical units away from the sun. And you can see all of the planets in the solar system and the sun, except for Mars and Mercury, since they're just not visible. The reason that it got the pale blue dot name was because when you look at the Earth, it literally just looks like this little pale blue speck on the image. So incredibly tiny, and it is a really gorgeous image. Fast forward a bit to December 2004, Voyager 1 became the first spacecraft to pass the solar system's termination shock, which is the point where the solar wind is slowed due to the pressure from the interstellar medium. It measured the speed of solar wind beyond the termination shock and showed that it moved slower than scientists had anticipated. It also took observations of the magnetic field in the area and showed that it had varied more slowly in the region than scientists had anticipated. Then in August 2012, Voyager 1 broke another record, and it became the first man-made object to travel into interstellar space. And at that point, its distance was about 122 astronomical units. Well, Voyager 1, an amazing spacecraft, it remains in operation today, just at a bit of a reduced capacity so that it can conserve power and continue operating for longer. It's currently only operating 4 of its instruments out of, I believe it was 11 that it has on board. It's currently the furthest man-made object from Earth at nearly 154 astronomical units from the sun, and is moving out of the solar system at 35,000 miles an hour, which corresponds to about 3.6 astronomical units every year. Voyager 1 is expected to keep at least one instrument in operation until about 2025, after which it's probably going to shut that down also, again, to conserve power, but can still remain in communication with the Earth and return some engineering data for another few years after that. NASA might end up losing contact with it around 2036 just because it doesn't have enough power to be able to communicate anymore. But still, 2036 would be amazing.
Yeah, that's incredible.
Yeah, an absolutely amazing mission. I gotta say that I think Voyager 1 and Voyager 2 are my favorite space missions. There's so many amazing ones, but these have to be some of the best.
Did they go to Pluto?
Sorry?
No, I was just trying to mention Pluto in passing.
Yes. Thank you. You're learning. Perfect. Yeah. I'm always happy to convert someone to also constantly talking about Pluto, because then maybe we can just get our own show one day and it'll be perfect.
Well, I'm the silent revolution behind Pluto, trust me. If we get status back someday.
But yeah, this is really interesting. I gotta say, and I think this is just me, my child, mind, but the Solar System Family Portrait, that title makes me picture all the planets lining up for a family photo, and you have a grumpy one, a sad one, and a happy one.
I think you can find some people who've done little cartoons of that.
Oh, really? I wanna see that.
Yeah.
Okay, are we talking about Voyager or Pluto now?
Everything. No, but let's stick to Voyager, because this is an incredible mission, and the fact that we can keep contact for another 15 years, that's amazing.
Okay.
So I think I am next, and I will be taking it a little bit further back in time. This is actually a very heartbreaking event. So on September 2nd, 1948, Sharon Krista McAuliffe was born. You might remember this name from the heartbreaking event that occurred on January 29th, 1986. On this day, Sharon boarded the Challenger space shuttle in Cape Canaveral, Florida. The shuttle exploded shortly after liftoff, killing everyone on board. Now, that might ring some bells, but I'll get into more of the story. Sharon was born in Boston, Massachusetts. When she was 5, her and her family moved to Framingham, Massachusetts, and she graduated from the Marion High School in 1966 and enrolled at State College, where she studied American history and education. She received a bachelor's degree in 1970. She began her career as an educator, teaching American history and English to junior high school students in Maryland. After earning her master's degree in education from Bowie State College in 1978, her and her family moved to New Hampshire. She landed her dream teaching job at a high school in Concord and gave birth to another child, so she was a family lady. She always had a dream of being a passenger on the space shuttle, so when NASA announced a contest to take a teacher up into space, she jumped at the chance and applied. And she won, beating out over 11,000 applicants. On January 28, 1986, her family and friends, including her 2 children, anxiously watched as the Challenger space shuttle took off from the Kennedy Space Center in Cape Canaveral. Her students in Concord also tuned in with the rest of the country to watch because this was obviously history making. We had a teacher going up and not someone who was like a trained astronaut. However, less than 2 minutes after liftoff, the shuttle exploded and sadly killed everyone on board. NASA spent months analyzing the incident, later determining that the problem was with the right solid rocket booster was the cause of the disaster. The findings revealed a gasket had failed on the rocket booster. The cold had affected the O-rings and a leak caused fuel to ignite. Thankfully, she was honored, though, so after her death, this courageous educator received the Congressional Space Medal of Honor. As a tribute to her memory, a planetarium in Concord was also named after her, as well as an asteroid and crater on the moon. In addition, there's now a Krista Corrigan McAuliffe Center at Framingham State College, and it was established, obviously, after she passed away to carry on her legacy and support the advancement of educational practices throughout the region. I don't remember this happening, obviously, because we were not born, but we studied this so often and heard about this story so many times. And, there's obviously videos. And I think the most heartbreaking part of all of this is that her kids were watching it. I couldn't imagine how awful that would be.
Yeah, I mean, it must be insane, especially, for everyone in her family going to watch someone that you love and care about do something that they've dreamed about for so long. And it's just, I can't imagine how happy you would be and going just total devastation in 2 minutes.
Yeah.
It's just horrible.
It definitely is, but there's also kind of a sad, peaceful side of this, that she died doing what her dream was. But I mean, that still doesn't make up for how horrific this event obviously was. And I don't think the deaths of NASA heroes and astronauts are talked about enough, because we always talk about the amazing spaces, flights that lift off and actually make it to planets or the ISS. But there's been so many obviously tragic disasters in the past that I think should be talked about more, because these are all people who gave their life to advance space exploration.
Yeah, I agree.
Yeah. I think we're on to Kshitij now, who's going to take us to the Viking 2 lander.
Oh yeah, sure. So I have something rather humble. Not the Viking 2 mission in general was humble, but this is the part which probably can be called humble. Just trying some humor here. So September 3rd, 1967 is when the Viking 2 mission's lander actually landed on Mars, and that's what we're talking about, or sort of celebrating today. So this was a 333-day cruise to Mars, for which the craft had been launched back in 1975. So this was a Titan launch vehicle which carried the orbiter to the Martian orbit on the 7th of August, and it had begun returning global images of the red planet by then. When it started orbiting. Now, the place called Utopia Planitia, I'm hoping I'm pronouncing this correctly, which is a 3,300 kilometer wide impact basin that was chosen as the landing site. And then the lander, when separated from the orbiter along with its aeroshell, it was orbiting at a mere 4 kilometers per second. I don't know if I could call it mere, but that's what it was. So the lander actually landed just about 200 kilometers west of the crater Mai, and that was the final touchdown. The cameras aboard this lander returned some really, out-of-the-world images, which I think since then have been frequently mimicked or probably used directly in space-based movies or documentaries. So the first color image presented a decidedly red-looking landscape, which is how we know the red planet as. And then there were other imaging which indicated that there was an occurrence of large floods on the surface sometime in the past on account of the scour patterns and erosions, which could be made possible only due to large amounts of flowing water. So maybe in layman terms, it's just saying there was a river somewhere. Or a flood, of course. So the mission scientists who were testing for biosignatures on the Martian terrain, they claimed a positive sign of life, although many other people argued it was a false positive. The lander itself operated on the surface, while being on the surface, till April 12, 1980, and after that, reportedly, its batteries died. So shout out to lander. Thank you.
That's first of all, I'm loving all of the planetary missions we're talking about, and there's actually more coming up. This is really interesting, but I gotta say, when I heard gay cruise to Mars, I for a split second thought there was a cruise to Mars and was very confused. But this is really interesting, but sadly the batteries failed.
Yeah, maybe they just said so. I'm the best conspiracy theorist in the world. Oh. Maybe it's still alive. It's sending more pictures and we're not getting to see them. But anyway, that's just part of the joke.
Yeah.
Nice.
I saw this funny photo. I don't know what a meme is anymore because I'm not cool with the kids, but it was on Twitter. And it was a little NASA rover, and I forget which one it was, and it was taking an image of what Mars looks like in the photos we get back, but two aliens were holding it on either side, we're faking them out, they don't see us. And part of me wonders, could that be happening? Or maybe these images being placed in certain ways that we don't see what's happening behind the scenes?
Well, see, conspiracy theorists always get something new.
Yeah.
Believe in, whatever.
Yeah, I remember not long after Perseverance landed, at around April Fool's, I think it was NASA or the CSA, they had a picture of a big pile of socks on Mars about where do your socks go when you lose them in the dryer? Well, they're on Mars.
I lose them all the time. That makes sense, but it actually gets me wondering what is happening above these images that we're not seeing, or on other areas of Mars that we just haven't really studied yet. Are we just missing something completely that could answer the question about life on Mars?
Yeah.
Is Matt Damon lurking in the background maybe?
Yeah.
There's so much of Mars that's unexplored. You always learn more when you send a lander down, so it would be interesting. You would, I guess, kind of assume that you have to go to the right spot to detect life.
Yeah.
So.
Yeah, that, and the chance of that, let's say we have a whole sphere that's Mars, the 0.0001% of surface area that could have life, we could just maybe never hit that spot.
Mm-hmm.
But it's definitely very interesting. But once I saw that photo, I'm not a conspiracy theorist. I don't read any of that. I'm fully against, Earth being flat, but that thinking so much just about since Mars is so explored, but also in the same way not, what are we just missing? And also that brings me back to Pluto. What are we missing on Pluto?
I think Pluto's flat. That's why it was.
Maybe it's flat. That could make that's the only logical reason for it being demoted. Maybe it's flat.
Oh man, you just want to go to Pluto so you can check it out yourself.
Want to go to Pluto so badly. I'll volunteer. NASA, just pay for it and just send me.
Hey, what about groceries and all? I I'm a foodie, so I can't do without that. I wouldn't be able to survive on the
I won't.
space.
Yeah, I'll have to like nitro freeze Popeyes or like McDonald's.
Nitro freeze.
or like I'll have to bring like Starbucks somehow, some way with me because I can't live without that.
Yeah, you would not do well without Starbucks.
Oh, I wouldn't. But if they could build me a spacecraft that can get me there with a Starbucks machine, I'll go. I'll die on Pluto. It's fine.
We've officially declared ourselves we're not science students anymore. Like, definitely not physics students. So.
We are conspiracy theorists. I'm just waiting for Hi Professor Delaney to make fun of me in the comments that I'm talking too much about Pluto. But on that note, I will turn it over to Sana to talk about the first OGO satellite launched.
Okay, so the Orbiting Geophysical Observatory, which is what OGO stands for, there's a series of 6 of them. So they were all NASA satellites that were launched between 1964 and 1969. They all had basically the same goals. They were all designed to study the Earth and its environment, specifically the Earth's magnetosphere, ionosphere, and atmosphere. But they also ended up taking some observations of high-energy radiation from the sun and the way that the sun and the Earth interact. Every one of these satellites carried about 20 to 25 instruments, which included magnometers, spectrometers, cosmic ray detectors, and even some telescopes. This was all kicked off with the first satellite, the Orbiting Geophysical Observatory 1, which was launched on September 5th, 1964 from Cape Canaveral in Florida. It was placed into a highly eccentric orbit that brought it to altitudes of about 150,000 kilometers at apogee, which allowed it to travel through some layers of the Earth's radiation belts so that it could study the magnetosphere. 2 other satellites, numbers 3 and 5, were also placed in similar eccentric orbits, while the remaining 3 missions, numbers 2, 4, and 6, were placed into polar orbits to allow for full coverage of the Earth when you combine all the satellites. While OGO-1 had 20 experiments on board, many of which were used to study the Earth. There were 12 experiments that were used for studying particles near the Earth. 2 of them were used to study Earth's magnetic field. And the rest were used for a bunch of different things, which included some radio astronomy observations. Most of the instruments performed as expected on the first mission, which made it a success. There were some issues with a couple of them, but by and large, everything worked and was managed to collect a lot of data. But another very important thing that this first mission accomplished was that it helped to create a standardized observatory satellite, which was very useful for planning future missions because it set out a useful design which they could use to base other things around. So very successful in terms of science and also in terms of the engineering perspective of it. Well, it operated for about 5 years until November 1969, and then it stopped receiving support in November 1971 since it was no longer transmitting data and being useful. Then, fast forward many, many years, it spent quite a long time just orbiting the Earth on its own. And then on August 29th, 2020, it burned up in the Earth's atmosphere over the southern French Polynesia. And when it burned up, it actually made it the first of the series of satellites to launch and the last to return to Earth, since all of the other ones had burned up in the atmosphere before OGO-1. Well, overall, the missions were all very successful. During their lifetimes, they observed some very powerful solar flares, they observed how solar wind interacts with the magnetosphere, and observed a daytime aurora for the first time, among many other things. So, happy anniversary to the launch of OGO-1.
That's amazing, and I'm ashamed to say as a physics student, I've never heard of OGO, like that whole satellite stuff. That's interesting, and the magnetosphere is obviously something that's incredible that needs to be understood. I would love to see a daytime aurora.
I need to go somewhere to see an actual aurora. I've only ever seen pictures of them. I still need to see one in person.
Oh, yeah.
Place called Yellowknife. I'm sorry I interrupted you. I was just saying Yellowknife is within the reaches of Canadian territory, right? Where you can actually go and watch aurora.
Oh, wow.
Yeah.
Yellowknife. Now, my grade 4 geography skills aren't kicking in. Where is Yellowknife? It's north.
I've heard it's somewhere up north, and I guess there's loads of mines over there, so I heard it from a friend of a friend. So that's all I can say.
It's in the Northwest Territories. That's what Google says.
Okay, I knew that. That's okay. So I guess we're planning a trip.
Yeah, as soon as COVID's over, we'll go travel to Yellowknife.
So in like 10 years, on the rate we're going.
Come on.
Oh God.
You have to be optimistic. You can't say that.
Okay, so in like 8 years and 6 more lockdowns. Let's see.
And we can settle at that, because if you keep trying, you'll probably come up with more numbers and
Yeah.
just the entire thing. So thank you.
We'll stop here. But I think my turn is next, and we're talking about another cool space mission. So September 1st, 1979, Pioneer 11 has the first flyby of Saturn. So Pioneer 11 was the sister spacecraft to Pioneer 10, and it was the first human-made object to fly past Saturn and also returned the first pictures of the polar regions of Jupiter. Pioneer 11 was boosted by its, funny name now, TEM-3644 engine, which allowed for the spacecraft to speed away from Earth at a velocity about 32,000 miles per hour, which is equivalent to about 52,000 kilometers per hour, which equaled the speed of its predecessor, Pioneer 10. During the outbound journey, there were a number of malfunctions on the spacecraft, including a momentary failure of one of the RTG booms to deploy, a problem with an altitude control thruster, and partial failure of the asteroidal dust detector, but none of these, thankfully, jeopardized the mission. The spacecraft crossed Saturn's ring plane beyond the outer ring at about 1436 UT on September 1st, 1979, and then passed by the planet at 1631 UT for a close encounter at a range of about 13,000 miles or 21,000 kilometers. It was moving at a relative velocity of about 71,000 miles per hour, conversion about 115,000 kilometers per hour, at the point of the closest approach. So, very fast. During the encounter, the spacecraft took 440 images of the planetary system, with about 20 at a resolution of about 56 miles or 90 kilometers. The images of Saturn's moons, Titan, showed a featureless orange fuzzy satellite. A brief burst of data on Titan indicated that the average global temperature of Titan was minus 315 degrees Fahrenheit, which is what I'm comfortable with, is minus 200 degrees Celsius. So it's freezing. It's very cold. And I gotta say that every time I think of Saturn, Sana, do you know what I think of?
Me and Cassini.
When I was writing this, I had a good chuckle, because every time I think of Saturn, I think of you crying on the bus about Cassini. So we won't talk about that. I just wanted to mention it for everybody.
I was sad that the Cassini mission was over. It was such a fantastic mission.
Oh, beyond, of course. But so was Pioneer 11 and Pioneer 10, and I think this is amazing. So we got really close, and the first flyby of Saturn, which led us to understand more about Titan.
Yeah, it was all of these missions are just so cool.
Yeah.
Honestly.
They really are, and the more we have these Monday radio shows, and the more I listen to them and research them, I realize how absolutely incredible these missions to planets are.
Mm-hmm. Yeah, I mean, just how challenging it would be to be able to actually send a spacecraft successfully to another planet, especially one so far away.
What's even more funny these days, when you do, when you Google something, or actually when you Bing something, Bing comes up with a chatbot saying, do you want to know more about what I just researched or searched? So not just us, even, chatbots will tell you more things about space missions. Just trying to chime in.
Oh, maybe we should have a conversation with a chatbot and just see how much we learn.
Yeah, that might be an interesting York Universe episode. We interview one of them.
Let's write that down. No, just write that down.
Yeah.
That is hilarious. But there's a lot of great missions we've talked about, which is all really interesting, and also gave us a lot of information on these planets that we can't quite visit yet in person, but I'm sure we will within the next 100 years. But I think Satish is going to end this segment off talking about a birthday.
Oh yeah, so I think is this the only birthday shout out we have today?
I think so.
Okay, well, so we saved the day, lastly probably. But anyway, so September 4th, 1958, this is a birthday shout-out for Jacqueline Hewitt. And she is an American astrophysicist. She was the first to discover an Einstein ring while she was studying a gravitational lens system. So, not that I'm any wiser, but an Einstein ring or an Einstein-Scholzen ring, as I would say, is a visual illusion created due to light rays bending or diverting when light from a galaxy or a star, when it passes by another massive gravitational influence or an object. So Hewitt was working with the very long baseline interferometry unit, which is a huge experiment or a huge thing in itself. So she was working with them during the years between 1986 and 88. That's literally when I was just born. Okay. So, well, she was a postdoctoral fellow then, and the gravitational lens system she was studying is, well, not surprisingly named MG1131, and then there's a plus sign that says 0456. So that's just, I'm getting the facts right. So she worked as a researcher at Princeton back then and has been an assistant professor for physics at MIT, a principal investigator with the radio astronomy group of the electronics lab at MIT. And as Wikipedia will have us know, she's been appointed and is active as the director of the MIT Kavli Institute for Astrophysics and Space Research since 2002. So, well, kudos to her, kudos to the lens system or whatever that thing is called. And thanks for listening.
I gotta say, every time we do a birthday shout out and we hear about the history and like the research they've done, I feel so inferior.
Imagine you would be, when you would be actually rubbing shoulders with people like these, and then people will hear about you. How will they feel? So maybe that will make you feel better.
That's amazing. So a happy birthday to Jacqueline Hewitt. I think that now takes us to the end of this week in History and Astronomy news. So you are listening to York Universe, broadcasting live from the Allan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. Please visit observatory.info.yorku.ca to chat, questions, content, or on Twitter at York Universe. Tonight you're listening to myself, Ariella, the main person trying to get Pluto a planet again, along with Shatij and Sana. We are currently just finishing to talk about the amazing life of Jacqueline and some of the amazing planetary flybys and missions we have not been part of, but have seen and watched, as they're all very incredible. You should swing by observatory.info.yorku.ca and click on online public viewing on the menu bar for OPV so you can join the chat, hopefully see live images. I'm not too sure what is happening with that or with the weather. And you can also keep up to date with what we were talking about here on York Universe. So hi to everyone currently running the OPV. So I think we have a few reminders. The main one is next Monday is a holiday for us Canadians. September 6th is Labor Day here in Canada, so there will not be a show. You will not hear from us next Monday. The perk of being Canadian. Monday off before school starting. We also have on September 14th, I know we're a bit early, but like I said, since we have a holiday next week, I want to remind everyone with ample time. Neptune will be at opposition. The blue giant planet will be at its closest approach to Earth, and its face will be fully illuminated by the sun. It will be brighter than any other time of the year and be visible all night long. This is the best time to view and photograph Neptune. Due to its extreme distance from Earth, it will only appear as a tiny blue dot, kind of like how Earth was when we were talking about it previously. That's still with the most powerful telescopes, but I plan to go outside and pretend I can see it because that would be amazing to see and photograph, and I'm really hoping Sana chimes in and says she's going to try to take photographs of it.
I don't think I can try and take pictures because the telescope that I have doesn't have tracking.
That's true too, yes.
So, yeah, imaging is a total pain. I might try and observe it, depending on where it is. I can't really use my backyard right now because there's a huge tree in there and there's like no room for my telescope. So, depending on where it is, I think I'm going to try and find it and observe it because it's been a while since I've taken my telescope out.
That's true. Same for me. I have a beautiful telescope my dad bought me that's currently hiding under my bed. So I think it's time to take it out because I love Neptune, and I would love to get a chance to observe that.
Yeah, that would be fun.
I think Sana has our next reminder.
Oh, yes. So if any of you like to keep up with what's going on the International Space Station, there's going to be 2 spacewalks coming up. These are Russian spacewalks from Expedition 65. There's number 49 happening on this coming Friday at 10 a.m. EDT, and then number 50 on September 9th. Both of these spacewalks will be preparing their new Nauka multi-purpose laboratory module to operate in space. So some of the things they're going to be doing is just connecting cables and Ethernet and power and other things that it needs to function properly. These are going to be the first of 11 spacewalks that are going to be fully preparing the module to operate in space. And NASA is going to be providing live coverage of this on their website if you would like to watch them. I always find spacewalks interesting to watch because it's just really cool seeing people on the outside of this massive space station orbiting the Earth. So if you're like me and you like to watch them on Friday and then on September 9th, got a couple spacewalks.
Amazing. Definitely is going to tune into that because I love seeing the floating people outside the ISS.
I know.
Oh, by the way, fun fact, the word, if it really is that word that I'm thinking, the word nauka, but that actually is also a word in Hindi.
Oh.
And that simply means a boat. So I'm not sure. Yeah.
Oh, that's cool.
That's cool. New fun fact.
Yeah, I'm not sure if the Russians actually stole that word from our language or they have something in their own language. I mean, of course, they can have, but I had to point it out.
Yeah. You need to make sure you take credit where credit is due. Exactly. I think we are going to move on to some news, and I think I'm actually starting us off. We have a really cool news this last little bit in astronomy. There is a new class of habitable exoplanets represent a big step forward in the search for life. So we might possibly have some more planets that we never thought to look at. So a new class of exoplanets that are very different from our own, but which could support life, have been identified by astronomers. This could now, of course, accelerate the search for life outside of our solar system because we'll have so much more planets to look at. In the search for life elsewhere, astronomers have mostly looked for planets of similar size, mass, temperature, and atmospheric composition to Earth. However, astronomers from the University of Cambridge believe there are more promising possibilities out there. The researchers have identified a new class of habitable planets dubbed Hycean planets, and that's spelled Hycean for anyone interested in researching it. These are not hot ocean-covered planets with hydrogen-rich atmospheres. These are more numerous and observable than Earth-like planets. This could mean that finding biosignatures of life outside of our solar system within the next 2 or 3 years is actually a real possibility. Many of the prime Hycean candidates are bigger and hotter than Earth, but still have the characteristics to host large oceans that could support microbial life similar to that found on some of Earth's most extreme aquatic environments. These planets also allow for far and wider habitable zones, and this is kind of dubbed the Goldilocks zone if everyone heard that, Earth is smack in between the Goldilocks zone. And if we have a wider range compared to Earth-like planets, there's a higher chance of finding a planet there. This means that they could still support life even though they lie outside a range where a planet similar to Earth would need to be in order to be habitable. Thousands of planets outside of our solar system have been discovered since the first exoplanet was identified nearly 30 years ago. The vast majority are planets between the size of Earth and Neptune and are often referred to as super-Earths or mini-Neptunes. Very good naming. They can be predominantly rocky or ice giants with hydrogen-rich atmospheres or something in between. Most mini-Neptunes are over 1.6 times the size of Earth, which is obviously smaller than Neptune, but too big to have rocky interiors like Earth. Earlier studies of such planets have found that the pressure and temperature beneath their hydrogen-rich atmospheres would be too high to support life. However, a recent study on the mini Neptune K2-18b found that in certain conditions, these planets could support life. Hycean planets can be up to 2.6 times larger than Earth and have atmospheric temperatures up to nearly 200 degrees Celsius, which is basically what we felt this weekend here in Ontario or Toronto. But their oceanic conditions could be similar to those conducive of microbial life in Earth's oceans. Hycean worlds are likely quite common, meaning that the most promising places to look for life elsewhere in the galaxy may have been hiding in plain sight all along. However, size alone is not enough to confirm whether a planet is Hycean. Other aspects such as mass, temperature, and atmospheric properties are required to confirm. A team at Cambridge identified a sizable sample of potential Hycean worlds, which are prime candidates for detailed study with the next-generation telescopes, such as the James Webb Space Telescope, which, hint, hint, nudge, nudge, has something to do with what Sana is talking about in the next segment. These planets all orbit red dwarf stars between 35 to 150 light years away, close by astronomical standards, which always gives me a good chuckle at how close is, like 100 light years away in astronomy. Planned James Webb Space Telescope observations of the most promising candidate, which is K2-118b, could lead to the detection of one or more biosignature molecules. Now, this is obviously really cool because the main thing you learn about in like a physics degree is, is where else is habitable. The Goldilocks zone, Earth being the, obviously the prime candidate of this, Mars potentially being next, but what could lie outside of the solar system? But we're always told it's kind of like one kind of planet. Do you know what I mean? Like it's like an Earth. But now we know that it could be kind of different. It could have a different habitable zone, could be bigger, different temperature, different mass, different size, and it could still actually support microbial life, which is amazing.
So, a partially scientific question. Why would they just call it mini Neptunes and not mini Plutos?
That's a good question. I'm very happy you asked that. The answer is I don't know. I don't know why they did Pluto in the first place. So, I mean, we can just like change it to mini Plutos because who's going to tell us not to? I mean, like no one, I'm hosting the show tonight. No one's going to come on and tell us not to.
I mean, you don't listen to anyone anyways. So
that's a lie. I listen to Delaney sometimes, but someone else. So, but no, that is very true. But on a serious note, this is actually incredibly exciting and interesting because can you imagine grad students in the next few years coming in, getting a chance to discover a planet that's habitable now that we know that there's these Hycean planets that could potentially harbor life? And we're always asked, like, as astrophysics students, is there life on other planets and is there little aliens? I know for a fact every time I'm with my dad, he asks me if I believe in life on other planets. So now anytime someone asks me this, we can almost say that there's a higher chance now because of these new planets that can be different from Earth and still habitate life.
Yeah, that's really cool. I love exoplanets. It's really interesting.
Yeah, this is really cool, and I this is actually just so exciting. Like I love exoplanets, I love planets. They're not my favorite topic, but now like hearing about this, it's just like there's a whole other world out there that we could have just been missing this whole time in plain sight that could actually hold more answers to us about life before human civilization.
Yeah. Another thing I find really interesting about this topic is how you can actually observe them with telescopes because these things are so dim in a lot of cases. So it's just wild to me that we can actually like use a telescope and directly image them or pick them up at all.
Yeah. And it almost makes me wonder, like, why was this not found before? And I know that's really bad to say, especially as researchers, we know that sometimes things just come up and you just learn things when you weren't actually looking for it. But I feel like in a sense we were so set on an Earth-like planet, Goldilocks zone similar to Earth, has to be an habitable zone, that we never took a chance of looking at potentially other planets that aren't too far out from us, that were just kind of chilling there the whole time. Like, hey, recognize me. There's like a little micro me.
Yeah, it might just be that, if you're trying to look for life, you're probably just trying to replicate the exact circumstances that led to life appearing on this planet.
Yeah.
So it's probably a bit of a bias where you're just kind of spending all your energy looking for the thing that you know might give you an answer and just kind of ignoring everything else.
Yeah, and that makes me wonder too, is there a Hycean 2.0, like somewhere out there also that's, different atmosphere, different makeup, different size, whatever, that could also have life, and we just haven't, as like civilization, picked up on it yet.
Yeah.
So, do you know what Hycean means?
I actually don't. I was too scared this whole time to just pronounce it wrong.
Okay, well, the chatbot says it's probably something to do with the color azure.
Oh.
I don't even know what that color is, but the chatbot is wrong, probably. I don't know.
Yeah,
sorry, go ahead.
No, that's really interesting. No, the thing I learned about astronomy names is sometimes they're just so random. Like, like planet 25-63b. So, like, sometimes with astronomical names, I don't look too into it.
My favorite, I think I told you about this, Ariella, my favorite new astronomy acronym is HOT DOG. Hot Dust Obscured Galaxy.
I'm so disappointed.
It was in a paper. I was really shocked when I saw it, but it's an actual term.
Now, isn't there something called like a snowball? Or am I thinking of something else? I feel like there's a snowball.
The blue snowball nebula, yeah.
That brings back memories.
When you called me a snowball?
Yes, exactly.
Wow. Okay. I didn't even know about that, so it's nice to know.
No, yes. I distinctly remember yelling at Sana and calling her a snowball after learning about that. Poor Shatish is just so calm and quiet and knowledgeable, and Sana and I just can't stop being ourselves.
Which is a very good thing. Very complimentary, is that the word?
Complimentary, because you bring us back to science, and then me and Sana just talk about calling each other snowballs in the middle of the day.
I'm trying to be funny myself because I tried with the chatbot again, and again I interrupted you, so you have to excuse me. But I tried asking the chatbot what it means, like what does the word exoplanet mean? I typed it, and it said, well, they don't know much about exoplanets. They may be something like our solar system. Fun fact.
What a politically correct answer. But I think now I'll take it to Sana to actually talk about this really cool telescope that might help us with these planets.
Yes, so this is a positive update about the James Webb Space Telescope, which is going to be the successor to the Hubble Space Telescope. It looks like it has finally completed its final grand test and is now ready for launch preparations. Anybody who has been following the story of James Webb knows that this thing has experienced a ridiculous number of delays over the years. NASA would just keep setting launch dates, and it keeps getting pushed back for a whole bunch of reasons. Sometimes it's funding problems because it is way over budget from what it was originally planned. Other times there are engineering problems, and there's even been a few natural disasters and, of course, COVID that ended up delaying its launch. But now it's looking like they set a launch date for late November or early December, and it's finally going to stick after all of these years of delays. Well, James Webb, just a bit of history on the observatory. It's a project that has been around for a very long time. Early discussions about a successor to the Hubble Space Telescope began at NASA in 1989, which, by the way, was before Hubble even launched. They were talking about this. And then the idea for James Webb specifically originated in 1996, but under the name the Next Generation Space Telescope. Over the next few years, it got its name in 2002 after NASA Administrator James Webb, who was critical to the Apollo program, and also underwent one massive redesign. So this observatory has been the culmination of essentially 30 years of work from thousands of people spread across 14 countries. It's all led by NASA, but it included some pretty major contributions from the European Space Agency and the Canadian Space Agency. So, fun fact about this is because the Canadian Space Agency was involved in this, Canada gets some guaranteed time on the telescope. If I remember correctly, it's about 5% of Webb's observing time goes to Canada. And if you're at York University or University of Toronto, there are a couple astronomers who are going to be using James Webb for observations. So, it's nice that it's kind of close to home for us. But anyways, a little bit more about James Webb itself. This telescope is absolutely amazing. It is the largest and most complex telescope that has ever going to be put into orbit. It has a 6.5 meter diameter primary mirror, which is made out of 18 hexagonal mirror segments. You have to use these mirror segments because the mirror and the telescope is so big that it actually won't fit into the launch vehicle. So you have to use these mirror segments so that it can, the mirror itself can fold up, launch, and then unfold when it's in space to observe the sky. James Webb is going to be used to observe wavelengths of 0.6 to 28.3 microns, which corresponds to about the color orange to the mid-infrared, which is possible because of the gold coating on its mirrors. It has a suite of 4 instruments: the near-infrared camera, the near-infrared spectrograph, the mid-infrared instrument, and the near-infrared imager and slitless spectrograph, or NIRISS, with the Canadian Space Agency contributing NIRISS and Webb's guidance system, the Fine Guidance Sensor, which is going to be used to accurately point James Webb while it's taking its observations and make sure it stays exactly where it's supposed to be pointing. Well, currently, James Webb is in California at a Northrop Grumman facility, which is NASA's main contractor for the telescope and was also responsible for assembling it. And on Thursday, it completed the final set of tests that were designed to make sure that it actually works in space. I think it finished construction in around 2016, so or was it 2018? Yeah, it finished construction quite a few years ago, and it's been undergoing tests and some changes ever since then. They're basically testing every component of this telescope because when it's in space, we won't be able to service it because it's so far away. So you really need to make sure that everything works, which is why it's been taking so long. But finally, after years, it's passed all its tests, and engineers have begun to prepare James Webb for shipping to Europe's spaceport in Kourou, French Guiana, where it will be launched by the European Space Agency's Ariane 5 rocket. They're expected to complete shipping preparations sometime in September, after which James Webb will travel by sea through the Panama Canal to French Guiana. After its launch at the end of this year, hopefully, if everything goes to plan, let's hope it does, then it's going to make its way to the Sun-Earth L2 Lagrange point, about 1.5 million kilometers away from Earth. It's going to take about a month to make this journey, then another few months to commission the observatory, and in total it's expected to finish commissioning about 6 months after its launch, and at that point it'll start taking observations. Once it's commissioned, it's going to be doing a ton of different stuff. It's expected to answer questions that astronomers have had for a very long time now, because there haven't been all that many new observatories like Webb coming online in recent years. It's going to study planets and moons in our own solar system. It's going to be studying distant planetary systems. There's quite a bit of its observation time is dedicated to studying planetary systems. It even has a couple of coronagraphs on the instruments, which are these instruments that are directly used to directly observe and directly image exoplanets. So it's going to be doing a lot of planetary observations. It's also going to be taking observations of the very early universe and taking observations that will hopefully help to answer some questions about dark matter and dark energy. So very exciting telescope that it's finally coming online. And one more thing I want to point out before I stop talking about this is that if you have a telescope that can track satellites, you can actually observe JWST yourself. So most of the time it's going to be about 16 to 18 magnitude, which is pretty dim, but under the right conditions you should be able to observe it. But when it has this massive sun shield to protect it and its instruments from the heat from the sun and the earth, and when this thing is oriented correctly, it's reflecting the sun's light directly back at Earth, and it can be as bright as 5th magnitude. So I think I will definitely be bugging Professor Delaney about using the 1 meter to take a picture of James Webb, and you can get your own picture as well.
Amazing. First of all, that's incredible and so impressive that we're finally going to have that, actually launching in the next little while. And so cool that we have profs. I think, Sana, aren't you going to be using some of the data?
Yes.
Why don't you just mention that? So Sana herself is going to be one of the few people lucky enough to get a chance, because some of the York Observatory profs have some time on it. And Sana is going to be a grad student, so she's going to be able to use some of the data, but she's just too coy to say that. So I'll say it. That's obviously incredible, and a huge congrats to Sana for being able to get a chance to work with this data before anyone else sees it.
It's going to be with the some of the guaranteed time observations from Canada, the Canucks survey, which are going to be imaging galaxy clusters.
Amazing.
Yeah, I'm excited.
I think then we just have, last but not least, Satish is going to take us to our final discussion for the evening.
Sure. Okay, so I hope we have just about enough time. So I am talking about interstellar comets. I'm sure most of us have heard about the comet Borisov, and people tell us with some recent research that, you know, those kind of comets, like which are not from the solar system, I think, or I guess yes, they're not rare, or they may not be rare. And although Borisov remains the first and the only interstellar comet to be, you know, sort of caught in the act by us, researchers Amir Siraj and Avi Loeb from the Harvard and Smithsonian grounds, they propose there may be more. So we mighty humans still need more or, you know, better technology to detect them, but their research published in the monthly notices of the RASC that points to the possibility of undetected interstellar as well as Oort cloud objects. The buzz is that there may be loads of interstellar asteroids in that region whose identity may not have been verified all this while. And they say it might just be because we never make a detailed effort and we kind of never follow through. So it is now more clear than ever before, though, that there may be more interstellar stuff in the lesser explorable regions of the Oort cloud than the people who claim to be members of this small little solar system. So Pluto has more competition coming up. Yeah, I just thought of this. But then this research effort is expected to get a lot more fuel once live next year. And that will also kick off the Taos 2 survey, which is short for the Trans-Neptunian Automated Occultation Survey. See, that's some good acronym.
Yeah.
So what they do for these efforts poised to go online this year itself. So the Taos 2 will probably be this year itself, and that will be at the San Pedro Observatory. So why should we be interested in such a research? Because it may help us reevaluate our understanding of the planetary formation process by virtue of their implied abundance, which points to a significant mass of material to be ejected in the form of planetesimals. So I'm also thinking maybe none of the planets that we still have, like the remaining 8 planets, maybe they will also be stripped of their status. Mm-hmm. That was a joke.
Yeah. No, I was just thinking, I was like, triggered. But that's really interesting. Changing the identity or haven't been verified. Sometimes even thinking of something that could be rare that's not rare once you look at a different area of space or learn more. It's all very interesting. That's why I think sometimes rules of what to follow or like criteria for space just doesn't work, because you seriously don't know what's out there.
Plus, the way they're talking about, the idea that we've been studying about this, the ejection of planetesimals, we have a certain bias in our mind already about how our solar system formed, or how the vicinity actually forms in general. So when, if at all, people do get into this kind of research, I've heard there's something called an arc nemesis of the sun also, or the solar system itself. Maybe we can find that one out too.
Yeah. Never heard of that, but that sounds really interesting. And it looks like this whole show basically led us to learning about space exploration, planetary exploration, and now just learning that, maybe they shouldn't be labeled, because maybe we should have to change the labels of all planets and or dwarf planets. But
Precisely.
I think that's it for everything tonight.
And before you do your outro, Ariella, we need to wish you a happy birthday.
Thank you.
Oh my God.
Thank you. I appreciate that. So everyone, you've been listening to York Universe, the astronomy and astrophysics program written and presented by students, faculty, alumni, and friends of York University. The hosts this evening have been myself, Ariella, make Pluto a planet again, Shatish, and Sana. Stay tuned because it is Astronomy Night in Canada. Coming up next is Quirks and Quarks, Western Worlds, and Science for the People. You can always connect with us on Twitter with the handle @YorkUniverse and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in to York Universe. Clear skies and have a good night.